Hi, hello everyone. Welcome back. As you all know, we are in chapter 4, algorithmic strategies. And this session could be the last session for chapter 4. So far, what I covered in these chapters are what is algorithmic strategies and the manipulation of data structure, searching, sorting, insert, update, delete, then characteristic of an algorithm. In that, we have seen input, output, fitness, definiteness, effectiveness, correctness, simplicity, unambiguous, and independent. Writing an algorithm. In that we have seen few examples. And algorithm and program. Comparison. Then analysis of algorithm. In that priori estimates and posterior testing. Then complexity of an algorithm. In that we have seen two complexity. One is space complexity and time complexity. Then efficiency of an algorithm, method for determining efficiency, then asymptotic notation in that big O, big omega, and big theta, best, worst, and average case efficiency, then searching techniques. In that we have seen two searching techniques. One is linear search and bubble search. Next, sorting techniques. In that bubble sort, we have seen bubble sort algorithm, and then insertion sort algorithm. This is bubble sort and insertion sort. And today I'm going to explain this selection sort. Today I'm going to explain insertion sort. You have seen bubble sort and selection sort. Today I'm going to explain insertion sort. Insertion sorting. Okay. Insertion sort is a simple sorting algorithm. It works by taking elements from the list one by one and inserting them in their correct position into a new sorted list. This algorithm builds the final sorted array at the end. This algorithm uses n-1 number of passes to get the final sorted list as per the previous algorithm as we have discussed. As usual, pseudocode I will explain later, and directly we will go to the example. And first, briefly I will explain, and then in detail we will see. Okay, in insertion set, it checks whether the first element, that is the first element, okay, is already sorted. If yes, it will move to the next element. Now compare with all the elements in the sorted list, that is sublist. See, this shaded place is called sorted list, and white portion which is not shaded is called unsorted area. This is sorted area, unsorted area. We will keep it like that. Okay. So what it will do, it will compare with the sublist. This is sublist. Okay. Then compare the element from outside. This is outside one. This will be compared here. Now the number will be moved to the buffer. A particular number. I'll give you an example. Now see here, 44 already sorted. 16. So 44 is greater than 16. So 16 will be moved to the buffer so that here space will be created, and 44 will be moved here. Now space will be created here. Now 16 will come back to this place. Understood? Is it clear now? Right? We will see the next one. Now here you see 16 is sorted, 44 is sorted. So both are in shaded area, marked area. Right? Now 83. Now 83 will be compared with 16. It's not smallest. 44, no, 83 is greater than 44 and 16. So this will come under shaded area. Right? Now 7. 7 will be compared with 16. Yes, 7 is lesser than 16. So 7 will be moved to the buffer. 7 will be moved to the buffer. Now 83 will take 07th position. 44 will take 83 position, value 83 position, and 16 will move to 44 position, and here space will be created. From the buffer, 7 will be copied or moved, whatever it is. Now you got an idea. Now next one. Now next is What is next? 67. 67 will be compared with 7. No. 67 is greater. 16. No. 44. No. 83. Yes. So 67 will be moved to the buffer. 83 will take 67th position. That is 67th value index position. And 67 will be moved here. 83 will be moved here. Now this will come under shaded area. Okay. Now 21. 21 will be compared with 7. No. 16. No. 44. Yes. Okay. So 21 will be moved to the buffer. Now this will be shifted. 21 will be inserted here. Understood? It's very easy only. Right? Now 34. 34 will be compared. 7. No. 16. No. 21. No. 44. Yes. 34 is lesser than 44. So 34 will be copied into the buffer. And all these elements will be moved towards right side. 34 will be inserted here. Is it clear? Now all these things will come under sorted area. Now 45. 45 will be compared with 7, 16, 21, 34, 44. No. Here, yes. So 45 will be moved to the buffer and 67 and 83 will be moved towards right side. Now 45 will be inserted here. And this will come under gray area, shaded area. Now 10. 10 will be compared with 7. No. 10 will be compared with 16. Yes. So 10 will be moved to the buffer and all the other elements will move towards right side. 10 will be inserted here. Now after inserting everything, you can see 0, that is 0, 7, 10, 16, 21, 34, 44, 45, 67 and 83. Everything is sorted. Is it clear? Shall we go to pseudocode? Now see here. Step 1. If the first element is already sorted, leave it. Now pick the next element. Compare with all the elements in the sorted sublist. This is sorted sublist. This is unsorted sublist. Okay. Now you compare with the sorted sublist. Shift all the elements in the sorted sublist with the greater than the value to be sorted. Okay. Now we are comparing that only. Now 83 is greater than 16. Yes. Don't sort it. Okay. Now 7 is greater than 16. No. 7 is lesser than 16. So you sort it. Understood? So insert the value. Repeat until list is sorted. Until the list is sorted. Understood? Everyone? Right? Next topic is dynamic programming. Dynamic programming is an algorithmic design method that can be used when the solution to the problem can be viewed as a result of sequence of decision. See, design method means it holds a technique to solve a given problem. It can be related to division and multiplication. Division and multiplication you already learned in mathematics, right? What is division? Repeated subtraction is called division. Multiplication, repeated addition. So it was a repeated technique to solve a problem. That means it was a repeated technique. It uses repeated technique to solve a problem. So dynamic programming approach is similar to divide and conquer. Already we have seen that divide and conquer. Can you remember? In the same chapter only. Yes, binary sort. So dynamic programming approach is similar to divide and conquer. The given problem is divided into a smaller and 8 smaller possible sub-programs. In first chapter, you learnt about modules, modular programming. In modular programming, each modules can be different. Each can be compiled separately. And each module will have input, process, and output. All the things you learnt. But dynamic programming is entirely different from modular programming. Right? We will see that now. Dynamic programming is used whenever problems can be divided into similar subproblems. Similar subproblems, so that the result can be reused to complete the process. That means one problem is divided into so many modules, right? Here what happened, this output will be input to this subprogram, this output will be input to this subprogram. So each and every subprogram will have link. But in modular programming, it is not like that. Each and every subprograms can be different. Understood the difference between dynamic programming and modular programming? Right. Dynamic programming approach are used to find the solution in optimized way. For every inner subprogram, dynamic algorithm will try to check the result for the previously solved subprogram. The solution of overlapped subprograms are combined in order to get the better solution. That means each subprogram output will be the input for other subprogram. Already I told you. And it goes on. Right? So, here, do you remember the concept what we have seen in chapter 1, 2? Right? That means in chapter 1, do you remember pure function? Can anyone tell the definition for pure function? Yes, for the same input, you will get the same output. Okay, so if the same input is called several times, it will give the same output. The same thing, same concept applies here. Same concept applies here, right? Now, steps to do dynamic programming. The given problem will be divided into smaller overlapping subprograms. That means the output of one subprogram will be the input for the next subprogram. That is called overlapping, right? An optimum solution for the given problem can be achieved by using result of the smaller subprogram. Dynamic algorithm uses memoization. Memoization. What is memoization? We are going to see that. Memoization is an optimization technique used primarily to speed up computer programs by sorting the result of expensive function calls and return the catch result. Catch is a temporary area, temporary memory, like RAM and ROM, right? Already you learned in 11th standard, cache memory, right? Catch result with the same input occur again. That's why I compared with pure function, right? If the input is same, what happens? If the input is same, the output will be same. That is pure function, right? So such type of things or functions will be stored in cache. And you know one thing, compiler only needs to call the function once. So the CPU time is saved. Understood now? We will see one example. Fibonacci series. Already you learned this in 11th standard. In C++, you had written a program, Fibonacci series, right? I will explain the same with example. Now already you know this program. Int f1 is equal to -1, f2 is equal to 1. I stored -1 and 1 in two different variables. And using for loop, I'm going to repeat this process 5 times. Okay. Now, -1 and 1, if you add it, you will get 0. So first value is 0, is printed, right? And then you are moving f1 is equal to f2. What is f2? f2 is 1. So f1 will get 1, right? And then f3 to f2. What is f3? 0. So 0 will be stored in f2. Sorry, 0. Okay. Right? And this will go back here. I plus 1. Now f1 plus f2. 1 plus 0 is 1. So 1 is printed here. Is it clear? So like this, the process repeats continuously. Here, if you notice one thing, the output of one function is the input for the same function. Okay. Now here, algorithm. First, we are initializing f1 is equal to -1, f2 is equal to 1. And then we are printing the interval f1 and f2, this one. And print the value stored in f3. We are printing it. Here, we are printing it. And we are assigning f2 to f1, f3 to f2. And finally, we are getting the output. So Fibonacci series iterative algorithm with dynamic programming approach we have seen, and the output is 0, 1, 1, 2, 3. Here if you notice, 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5. See here, one output becomes input to the next one, right? 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is 21. It goes on like that. Understood about dynamic programming? Even one more example I can give, that is factorial of given number. Factorial of given number is also like that, 1 into 2 into 3 into 4 into 5. Understood? So one function's output will be the input for the another function. Is it clear? So today I completed chapter 4. Today the topics I covered: dynamic programming, steps to do dynamic programming, and then I explained about insertion sort. In previous classes I covered selection sort, then bubble sorting algorithm, then searching. In searching, under searching, I explained about binary search, and then linear search, right? Then I explained about asymptotic notations, big O, big omega, and big lambda, best, worst, and average case efficiency. Then method for determining efficiency, and then complexity of an algorithm in that time factor and space factor, efficiency of an algorithm, priori estimates and posteriori testing, okay, and then comparison between algorithm and program, then characteristic of an algorithm, input, output, finiteness, okay, not fitness, finiteness, definiteness, effectiveness, correctness, simplicity, unambiguous, and independent. Is it clear? And then introduction to algorithmic strategies. In that, manipulation of data structure, search, sort, insert, update, and delete. So chapter 4 completed, and everyone see entire chapter is completed. And so I want everyone to go through the videos again and again. Still, if you have any doubts, you can ask me. See you. Take care. Bye.